Okay, so the last section in cellular respiration is known as the electron transport chain. You guys have been hearing a lot about it, so we're going to go into some details surrounding it and hopefully clarify any misconceptions you guys have. So the electron transport chain uses the high energy electrons from the Krebs cycle that we just talked about to convert a dp into a tp. So you have high energy electrons from NADH and FADH2 are passed alongside the electron transport chain. The electron transport chain is composed of a series of carrier proteins located in the inner membrane of the mitochondrion. High energy electrons are passed from one carrier protein to the next, and at the end of the electron transport chain is an enzyme that combines these electrons with hydrogen ions and oxygen to form water. Oxygen serves as the final electron acceptor of the electron transport chain. Thus, oxygen is essential for getting rid of the low energy electrons and hydrogen ions, which are the waste of cellular respiration. So to rephrase that, the waste of cellular respiration are the low energy electrons and the hydrogen ions. So basically, we're going to talk a little bit about these hydrogen ions and what's happening. I couldn't find a better picture, so you're going to kind of have to bear with me. So every time two high energy electrons transport down the electron transport chain, their energy is used to transport those beautiful hydrogens across the membrane. During the electron transport, hydrogen ions build up in the intermembrane space, making it positively charged, which you can see here, very positive. And then on the other side of the membrane from which those hydrogens are being taken, over here, you see the hydrogens going to this side becomes more negatively charged. You probably are wondering, how the heck does the cell use the charge difference that builds up as a result of the electron transport? The inner membrane of the mitochondria contain protein spheres called ATP synthase, so that's this guy right over here. As hydrogen ions escape through channels in these proteins, the ATP synthase basically spins. So each time the ATP synthase, this little guy, rotates or spins around, the enzyme basically grabs a low energy ADP and attaches a phosphate, which, as you guys know, creates ATP. So every time it spins, it attaches a phosphate. You can see that right here. So it spins, attaches phosphate, gets ATP. The beauty of this system is the way in which it couples the movement of high energy electrons with the production of ATP. So here's our high energy electrons and our ATP. Every time a pair of high energy electrons moves down the electron transport chain, the energy is used to move hydrogen ions across the membrane. These ions are then rushed back across the membrane, producing enough force to spin this beautiful ATP synthase and generate enormous amounts of ATP. On average, each pair of high energy electrons that moves down the electron transport chain provides enough energy to produce 3 molecules of ATP. So basically,